Let's solve this problem about electrical transients. A series RLC circuit has R resistor is equal to 40 ohms, L inductor is equal to 100 millihenry, and C capacitor is equal to 50 microfarads. The circuit is connected across a 100 volts DC source at time is equal to 0 through a switch. Determine the current 0.02 second after the switch is closed. Assume all initial conditions to be 0. So the very first step in solving RLC circuit is to determine which category it falls on. So remember the formula, R over by L, that is squared, minus 4 over by L times C is equal to, if that is positive, that is overdamped. If that is 0, that is critically damped. And if it is negative, that is underdamped. Plugging the values in the problem, R is equal to 40, L is equal to 0.1, that is squared, minus 4 over by 0.1 times 50 times 10 raised to negative 6, that is equal to negative 640,000. So since this is negative, therefore the case is underdamped. So I assume that you are already familiar with the formula of instantaneous current in underdamped case. So I will just write the formula since I will not be explaining that in this video. That is I is equal to e raised to alpha t times c sub 1 cosine of beta t plus c sub 2 sine of beta t. Solving for the solutions of the auxiliary equation, which are alpha, the real part which is equal to negative r over by 2l, and the imaginary part which is beta, that is equal to positive or negative square root of absolute value of r over by l squared minus 4 over by LC over by 2. For this particular problem, alpha is equal to negative 40 over by 2 times 0.1, that is equal to negative 200. And the imaginary part is equal to positive or negative square root of 640,000 over by 2. Therefore, beta is equal to positive or negative 400. Plugging those solutions in our first working equation, we get I is equal to e raised to negative 200 t times c sub 1 cosine of 400t plus c sub 2 sine of 400t. Now, the initial conditions is 0, therefore, at time is equal to 0, I is equal to 0. Substituting that, we get 0 is equal to e raised to 0, which is 1, c sub 1 cosine of 0 is 1, plus since sine 0 is equal to 0, therefore that is also equal to 0. Therefore, c1 is equal to 0. So, I is equal to, simplifying this, we get e raised to negative 200 t c2 sine of 400 t. Now, let's say this is our equation 1 and this is our equation 2. So we need to produce more equations to solve for the instantaneous current. So differentiating our equation 2, we get di over by dt is equal to, let's copy the c2, c sub 2, e raised to negative 200t times the derivative of sine 400t, that is 400 times cosine of 400t. Then sine 400t times the derivative of e raised to negative 200t, which is negative 200 e raised to negative 200t. Simplifying this, let me just fix this. Di over by dt this is now our equation 3. By KVL, we can produce another equation, that is E, which is the source, minus voltage drop across the resistor minus the voltage drop across the inductor, that is L times di over by dt minus 1 over by c integral of I dt, that is the voltage drop across the capacitor, and equal to 0. The initial conditions says that I is equal to 0, therefore this is 0 and this is 0, therefore our di over by dt can be determined by dividing the voltage by the inductor or the inductance. So in the problem, the E voltage source is 100 and the inductance is 0.1. Therefore, our rate of current is 1000 amperes per second. So substituting the rate of current in our equation 3, we can now solve for C sub 2. At time is equal to 0, that is 1000 is equal to 200 C sub 2, e raised to 0 is 1, cosine of 0 is 1, that is 2, minus sine of 0 is 0. So therefore our C2, C sub 2 is equal to 1000 over by 2 times 200, that is 400, is equal to 2.5. Rewriting our equation 2, that is I is equal to, and the value of our C sub 2 is 2.5. Now, finally, we have the formula of instantaneous current for this particular problem. That is 2.5 e raised to negative 200t sine of 400t. So we are asked to solve for the instantaneous current at time is equal to 0.02. Solving for that, that is 2.5 e raised to negative 200. Substitute time, that is 0.02 sine of 400 times 0.02 multiply by 180 over by pi, since this is in radians. Therefore, we now get the instantaneous current at 0.02, which is 0.0453 amperes, or 45.3 milliamperes. So I hope I helped you in this problem, and please do me a favor by subscribing to my channel. Thank you.